I welcome you all to the last part of Module 4. In this topic, we will be discussing about D'Alembert's principle. Initially, we will be seeing what is D'Alembert's principle and a few problems related to that. So, consider a body which is acted upon by different forces. Let the forces be F1, F2, F3 and F4. So, if the net force is along this direction, what happens? This body will be moving towards right with an acceleration A. And all these things can be found out by Newton's second law, which is net force equal to mass of this body into acceleration. Now a small change has been made by D'Alembert. Consider the same body itself which is acted upon by different forces F1, F2, F3 and F4. Normally it will be moving towards right. Now if this body is to remain in static equilibrium, what should be done? We should be applying an imaginary force or a virtual force in the opposite direction. Or in other words, we can say that as all these bodies are in motion, for the dynamic equilibrium of the body, if the net force is in this direction, there should be an opposite force in the other direction, and this opposite force is termed as inertia force, which is equal to m into a. Or we can say that for the dynamic equilibrium of the body, the sum of resultant force, let it be represented by F, and the reverse force should be 0. That reverse force is inertia force. Or we can say that if F is the net force and ma is the inertia force, F minus ma equal to 0. Or in statement we can see that it states that the system of forces acting on a body in motion is in dynamic equilibrium with the inertia force of the body. Or in other words, the body will be in dynamic equilibrium under the action of external force F and inertia force. So if you are simply saying it is just F minus ma equal to 0, net force minus mass into acceleration equal to 0, while in Newton's second law it was net force equal to mass into acceleration. Here in D'Alembert's principle it is net force minus mass into acceleration equal to 0. Let us start the problems, but before starting you should be having a thorough idea on the previous portion, which is motion of connected bodies, which we discussed already in part 5 and part 6, because it is the same problems what we will be doing over here also. In that case, motion of connected bodies, we did all those things by Newton's second law, which is net force equal to mass into acceleration, while in D'Alembert's principle we will be doing the same problems by the equation net force minus mass into acceleration equal to 0. So let us see the problems, then it will be more clear. So the first problem is, an elevator has a downward acceleration of 1 meter per second square. Find the pressure exerted by the floor of the lift when a man weighing 700 Newton is traveling in the lift. What is the pressure if the elevator is moving upward with the above acceleration? Use D'Alembert's principle. So what we did over there, initially we will be drawing a figure. So there is a lift, a man is standing inside the lift. He is weighing 700 Newton, that is weight is acting downwards. It has been asked to find the pressure exerted by the floor. We represented this pressure by the term R. So let R be the reaction from the floor. Here there is the floor. Here there will be a reaction. That reaction is represented over here. In the first case is when a man weighing 700 Newton is traveling in the lift, it is downward acceleration. So first case is motion is downwards. Acceleration is downwards, which is given as 1 meter per second square. Now by D'Alembert's principle, an additional term has to be added, which is ma, that is inertia force, and it will be opposite to the direction of motion. So you should represent this ma also in the opposite direction to that of motion. So all those things should be there in your figure. Weight is acting downwards, reaction, motion, acceleration downwards, and opposite to the direction of motion there is inertia force, which is mass into acceleration. Now by D'Alembert's principle, it is net force minus mass into acceleration equal to 0. So net force, what is the net force in the downward direction? It is W minus R. W minus R minus mass into acceleration. So what is mass? It is 700 divided by 9.81 into acceleration is 1 meter per second square. So 700 minus R minus 700 divided by 9.81 into 1, you will be getting the reaction which is 628.64 Newton. So that was the first case. Similarly, the next case, upward motion. What is the pressure if the elevator is moving upward with the above acceleration? So the motion is upward. The same figure, man is standing over here, weight is acting downwards, there is a reaction from the floor, motion is upwards, acceleration is upwards, which is 1 meter per second square. Then there is an inertia force opposite to the direction of motion. Now by D'Alembert's principle, it is net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? It is R minus W. In the direction of motion, R is positive and W is negative. So R minus W minus MA equal to 0. So R minus 700 minus what is M? It is 700 divided by 9.81 into acceleration is 1 equal to 0. So you will be getting R equal to 771.36 Newton. That is the pressure exerted by the floor when elevator is moving downward is equal to 628.64 Newton, and the pressure exerted by the floor when elevator is moving upward is 771.36 Newton. Next problem. Two blocks of masses 10 kg and 5 kg are connected by an inextensible string as shown in figure. Assume mu between 10 kg mass and horizontal surface as 0.25. Find acceleration of the blocks and the tension in the string. Use D'Alembert's principle. So the figure is given in the question itself. 10 kg is resting on a horizontal surface. It is connected by a string passing over a pulley, and there is a 5 kg mass which is hanging free in air. Now we know that the tension in the string will be same, that it will be represented by T. What we normally do is we will be drawing the free body diagram of each block individually. So this is the first case for 5 kg mass. For 5 kg mass, 5 will be acting downwards. Tension T will be acting in the upward direction. Now what will be the direction of motion? As 5 kg is hanging free in air and 10 kg is on the horizontal surface, anyway this will not be moving towards left. So the only case is 10 kg moving towards right and 5 kg moving downwards. So for 5 kg mass, direction of motion is downwards, acceleration is downwards. Then the inertia force will be in opposite direction, which is given by MA. Now again we'll be representing this in terms of weight. So the given thing is mass, 5 kg mass, convert into weight, which is 5 into 9.81. Now by D'Alembert's principle, it is net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? It is 5 into 9.81 minus T. So this is first case minus MA, which is minus 5A equal to 0. Simplifying, you will be getting this. Let it be equation 1. Now for 10 kg mass, the direction of motion is 10 kg will be moving towards right. So this is the direction of motion, towards right. If this is X, it is moving in the X direction. So the acceleration will be towards right. Now 10 kg weight acting downwards, mass acting downwards, so convert into weight. So it is 10 into 9.81. There will be a tension in the string. Now again, as the surface is rough, coefficient of friction is given, so which means the surface is rough. As the direction of motion is towards right, there will be a frictional force towards left. Frictional force is represented by F star, which is equal to mu into R. Now how to calculate this R? Summation of force in this direction will be equal to 0, which means R minus 10 into 9.81 equal to 0. So you will be getting R. Now by D'Alembert's principle, net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? It will be T minus F star minus M into A equal to 0. What is F star? It is mu into R. Mu value is given as 0.25. R value we already got. So just substitute over here. You will be getting second equation. Now solving equation 1 and equation 2, you will be getting the acceleration, which is 1.64 meter per second square. Substitute this A in any of the equations and you will be getting the tension. Next question. A block of mass 150 kg lying on an inclined plane of angle 16 degree is pulled up by another block of 80 kg connected by a string as shown in figure. The coefficient of friction between inclined plane and block 150 kg is 0.2. Find acceleration of each block and tension in the string. So the figure is given in the question itself. there is 150 kilogram. If it is expanded, so there is 150 kilogram which is resting on an inclined surface. The angle of inclination is 16 degree. It is pulled up, so the direction of motion is upwards. This will be downwards. It is given in the question itself. An 80 kilogram is hanging free in air. So what we do is, for 80 kilogram mass we will be drawing the free body diagram. So it will be like this. For 80 kilogram mass, free body diagram is, the mass is given, so we should convert into weight. So for 80 kilogram, 80 is acting downwards, it is converted into weight, so it is 80 into 9.81. There is a tension in the string, let it be represented by T. Direction of motion is downwards, acceleration is downwards, so inertia force will be in the opposite direction. Now by D'Alembert's principle, net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? It is 80 into 9.81, 80 into 9.81 minus T, so this is the first case, minus MA equal to 0. M is 80 kilogram itself. So similarly for 150 kilogram mass, this is the free body diagram. So it is expanded. 150 kilogram acting downwards, making an angle 16 degrees, so this will be 16 degree. So along the motion and perpendicular to the motion, it is 150 into 9.81. Since this is mass, we have converted into weight, so it is 150 into 9.81 into cos 16, and this will be 150 into 9.81 into sin 16. Now the direction of motion will be upwards, as it is given in the question itself. So direction of motion is upwards. As this is a rough surface, since coefficient of friction is given, it is a rough surface, so frictional force will be in the direction opposite to that of motion. So F star equal to mu into R. Mu value is given as 0.2. How to find R? In this direction, the summation of force is 0. So R minus 150 into 9.81 into cos 16 equal to 0. So from that you will be getting R value, which is 1414.5 Newton. Now by D'Alembert's principle, net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? It is T minus F star minus 150 into 9.81 into sin 16 minus MA. M means it is 150 into acceleration, it is A itself. So you will be getting the second equation. Solving equation 1 and equation 2, you will be getting the acceleration. Since acceleration is same for both blocks, you can just write acceleration for both blocks equal to 0.42 meter per second square, and tension in the string equal to 751.2 Newton. Next question. Two blocks of weights 750 Newton and 1500 Newton starts from rest as shown in figure. Mu between 750 Newton and inclined plane is 0.2. Find the acceleration of each block and the distance traveled by 750 Newton in 2 seconds. So the figure is given in the question. It is 750 Newton resting on inclined surface, making an angle 30 degree. It is connected by a pulley, and there is a string. There is another pulley here. The weight of that, the weight attached to it is 1500 Newton. So this type of problem we have seen. Normally there will be a pulley as well as a string only. In one of the problems in motion of connected bodies, we have seen a pulley connected by 2 strings. So the same method should be applied here also. What was done over there? If this 750 Newton moves up by x, then 1500 Newton will move downwards by x by 2 only. So we already told the reason for that. Similarly, if the acceleration of 750 Newton is a, then 1500 Newton will be a by 2 only. Now we will be drawing the free body diagram of each one. So first one, for 750 Newton weight, it is on the rough inclined surface, so it is 750 acting downwards, making an angle 30 degree. So this will be 30 degree. This is 750 cos 30, 750 sin 30. It is connected by a string, so T is the tension in the string. As this is a rough surface, because mu value is given, so it is a rough surface. Direction of motion is upwards, which means frictional force will be downwards. F star equal to mu into R. Mu value is already given, which is 0.2. In order to find R, it is in this direction, it will be 0. Summation of force will be 0. So R minus 750 cos 30 equal to 0. So it is R equal to 750 cos 30, you will be getting 649.52. Now the acceleration is A itself, and along with that we will be applying the inertia force. This has to be shown in the figure if it is by D'Alembert's principle. So opposite to the direction of motion, there will be inertia force which is equal to ma. Now let us see the equations. By D'Alembert's principle, net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? Motion is upward, so it is T minus 750 sin 30 minus F star. T minus 750 sin 30 minus F star minus ma. M value is, weight is given as 750, so it is 750 divided by 9.81 into a. Simplifying, you will be getting this equation. Similarly, for 1500 Newton, it is like this. There is a pulley, weight is acting downwards, 1500 Newton. There are two strings. So let T be the tension in the string. T will be same throughout. Now we already told that 1500 Newton block will be acting downwards. Acceleration is downwards. Inertia force will be in opposite direction, which is ma. Now by D'Alembert's principle, net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? It is 1500 minus t minus t. Then minus mass into acceleration. What is mass? It is 1500 divided by 9.81. What is acceleration? It is a by 2. So here also it is a by 2. ma instead of acceleration, actually this acceleration is a by 2, so represent it as ma by 2 itself. So this is equation 2. Solving equation 1 and equation 2, you will be getting the final acceleration as 2.14 meter per second square. This acceleration is for 750 Newton block. A means it is for 750 Newton block. So for 1500 Newton, it will be a by 2. So acceleration for 1500 Newton block will be equal to a by 2, which is 1.07 meter per second square. Now what was asked in the question? Find the acceleration of each block. We have found out that one. And the distance traveled by 750 Newton in 2 seconds. Distance traveled by 750 Newton. So it starts from rest, which means initial velocity is given, time is given, acceleration we found out, the distance is to be found out. So we have the equation S is equal to ut plus half at square. While substituting, you will be getting S is equal to 4.28 meters. This is for 750 Newton block. Now if it was to find the distance traveled by 1500 Newton, it will be the same equation itself, S is equal to ut plus half at square. But remember that this acceleration will be for 1500 Newton block, which is 1.07 meter per second square. As this is for 750 Newton block, we have applied this acceleration itself, which is 2.14. Let us see the last question. Two blocks of masses 5 kg and 10 kg are placed on two inclined planes of inclinations 30 degree and 60 degree connected by a string as shown in figure. Mu between blocks and plane is 0.33. Find the acceleration of each block and tension in the string. So the figure is given in the question itself. Two blocks 10 kg at 60 degree and 5 kg and at 30 degree are on inclined surfaces. Now what we want to do is, the tension will be same throughout. Let T be the tension. Now assume that as this 10 kg weight is greater than 5 kg weight, this is moving downwards and this 5 kg is moving upwards. So we will be drawing the free body diagram. So first case, free body diagram of 10 kg mass. So 10 kg, this is mass. So we have to convert all this in terms of weight itself. So 10 kg acting downwards, we have converted into weight. So it is 10 into 9.81. It is making an angle 60 degree. So this will be 60 degree. This will be 10 into 9.81 into cos 60, and this will be 10 into 9.81 into sin 60. Now there is a tension. Let it be represented by T. As the surfaces are rough, there will be a frictional force and there will be a reaction. Let R1 be the reaction from the first surface, and let F1 star be the frictional force. Now what will be the direction of motion? 10 kg is moving downwards. So the direction of motion is downwards. Acceleration is downwards. We will be applying the inertia force in opposite direction, which is ma. So as the direction of motion is downwards, frictional force will be upwards. So F1 star equal to mu1 into r1, or we can represent it as mu itself, since the mu between blocks and plane is same for all the cases and it is 0.33. So we can represent it as mu itself into r1. Now how to calculate r1? Summation of force in this direction will be equal to 0, which means r1 minus 10 into 9.81 into cos 60 will be equal to 0. So you will be getting r1 as this one, 49.05 Newton. Now by applying D'Alembert's principle, net force minus mass into acceleration equal to 0. What is the net force in the direction of motion? 10 into 9.81 into sin 60 minus t minus f1 star. So up to this it is okay. Minus mass into acceleration equal to 0. So what is f1 star? F1 star is mu into r1. Mu value is given as 0.33 and r1 is, we already calculated the value of r1, which is 49.05. Substitute all those things in the equation and you will be getting equation 1. Similarly, for 5 kilogram mass, it is the direction of motion is upwards, acceleration will be upwards. This is the 5 kilogram mass, vertically downwards. So convert into weight, it is 5 into 9.81. Angle is 30 degree, so this will be 30 degree. This is 5 into 9.81 into cos 30. This will be 5 into 9.81 into sin 30 along the motion, and perpendicular to the motion we got the values. There is a tension T. Now as the surface is rough, there will be a reaction, let it be represented by R2. As the direction of motion is upwards, this friction force will be downwards. So it is F2 star, which is equal to mu into R2. And along with that, there will be an inertia force also, which will be equal to ma, opposite to the direction of motion. Now how to find this R2? R2 minus 5 into 9.81 into cos 30 equal to 0. So from that you will be getting R2 value equal to 42.48 Newton. Now along the motion we will be applying D'Alembert's principle. So along the motion means it is T minus 5 sin 30 into 9.81 minus F2 star. So up to this it's okay. Net force minus mass into acceleration equal to 0. Mass is 5. We already got the values of this. So from this you will be getting equation 2. Solving equation 1 and equation 2, you will be getting the acceleration, which is 2.01 meter per second square. And you have been also asked to find the tension. Substitute A in either equation 1 and 2, 1 or 2. You will be getting the tension, which is 48.68 Newton. So that's all about D'Alembert's principle. If you know motion of connected bodies, then there is nothing to study in D'Alembert's principle. It is just net force minus mass into acceleration equal to 0. Now, these were the portions to be covered in module 4. Kinematics, which we discussed in part 1. Kinetics, it was discussed in part 2. Projectiles in part 3. Impulse moment also we discussed in part 3. Work energy concept we discussed in part 4. Motion of connected bodies in part 5 and 6. D'Alembert's principle in this part, which is part 7. Now some general instructions. Don't just read and study engineering mechanics. Do the problems on your own. So keep some papers, pen and pencil along with you. After seeing each question and answer from the video, do it on your own in the paper itself. If you're reading mechanics, you can't find the mistakes. While writing only, you will be finding the mistakes. And also if you're writing it, it increases your speed of writing also. And also feel free to ask the doubts. Thank you.